So thanks very much for accepting the paper. It's great to be here, and it's really nice to talk to the audience, and especially get the feedback of philosophers on this work. So this is a paper that grew out of the last paragraph of a much bigger paper that I've done with Jeff Hill on intertemporal choice when preferences are heterogeneous. And when I was writing this last paragraph, this kind of problem occurred to me in some of the reasoning, and it turned out that this paper was actually quite rich, and I have the paper before you. So what is the question we're asking? So this paper is concerned with pure intergenerational altruism. It's also called non-paternalistic intergenerational altruism. So what does that mean? So any time preferences that you might have seen, so discounted utilitarianism or hyperbolic discounting models, are usually thought of as, well, at least with respect to this literature, they're thought of as paternalistic in the following sense, in the sense that I decide what my attitude to future generations or future time periods is, and that's what it is, right? So I get to choose unilaterally what my attitude to your future utility is. So, and there's some preferences, there's some weights on future utilities that determine what I think, right? For non-paternalistic altruism, I don't just care about the flow of utility that future generations experience, I care about their comprehensive well-being. And if those generations are themselves altruistic towards future generations, their well-being will depend on the well-being of their descendants, right? So this is a model where I don't get to say how I should evaluate the well-being of other people in succeeding generations. I respect whatever their preferences are, and if those preferences happen to be altruistic with respect to future generations, then my evaluation of their well-being is consistent with theirs. Now I should say, I get to choose how to weight their preferences in any way that I like. I haven't lost any agency by doing this. But what I am doing is allowing a completely non-paternalistic representation of what their preferences are. I'm not imposing my own views on how their well-being should be evaluated. And you'll see how this works out in a minute. So there's actually a substantial literature in economics, in economic theory, that sort of looks at these kinds of preferences, non-paternalistic preferences, and the usual game is to kind of take these co-determined, mutually interacting preference systems, because if my preferences depend on your preferences and your preferences depend on your descendants, then there's a kind of interaction between our different preferences, and unwind them back into standard paternalistic preferences, which we all know and love and are used to using. And the game is to try and understand how the properties of non-paternalistic or pure intergenerational altruism preferences relates to the properties of these as-if paternalistic preferences. So that's the game that we're going to play. And so there's a lot of literature going back to the 70s that does this. When I read this literature, it really only occurred to me because I was doing the other paper on heterogeneous preferences and intertemporal choice. All the models of these pure intergenerational altruism assume homogeneity in preferences. That means that if my pure intergenerational preferences are one thing this generation, then it must be that everyone in the next generation has the same intergenerational preferences as I do in this generation. But of course, this is actually a paternalistic assumption if preferences are in fact heterogeneous, right? Because it amounts to saying that no matter what your intergenerational preferences are in the next period, I'm going to evaluate your well-being as if you share my preferences. So that's what homogeneity amounts to in the case where preferences are in fact heterogeneous. And now, so are preferences heterogeneous? So I'm actually not going to talk about that because we're going to have some presentations later that will address that question. But certainly, anecdotally, if you look at debates about pure time preference in philosophy as well as in economics, anecdotally, preferences are certainly heterogeneous. How much attention we should pay to that heterogeneity is an ethical question, which I'm not going to address. I'm just going to take heterogeneity of preferences as given and look at the relationship between heterogeneous models of pure intergenerational altruism and the existing homogeneous models in the literature. So the goals of this paper are actually quite circumscribed. All we want to do is put heterogeneity into these models and see what this does to the findings. So to give you an example of what pure intergenerational altruism looks like, here's the simplest possible example. So imagine that I am in generation tau, and I care about the flow of utility that I experience in this generation, and the comprehensive well-being of the next generation, my kid's generation, right? So I get some benefit from utility, and I discount the next generation's utility with some discount factor beta. Well, so this, I'm going to call this a first order model because my intergenerational altruism only extends to the one generation into the future. Okay? And so the game that we can play is to try and turn these entangled preferences here into disentangled preferences where my own preferences just depend on the flow of utility to future generations. And the way that we do that is to just repeatedly substitute this relationship into itself, right? So I can write ut as given, but then v at tau plus 1 is just using the same relationship, u at tau plus 1 plus beta v at tau plus 2, and then I can replace v at tau plus 2 with the same thing for v at tau plus 3. What you find is you get a whole bunch of exponential discount factors that come out multiplying each succeeding utility, right? So what you end up with, of course, is that my current preferences are exactly the same as just discounted utilitarian preferences over all succeeding generations, right? So first order, homogeneous, pure intergenerational altruism gives me discounted utilitarianism. This is actually, this is certainly in the literature. It goes back to Barrow, actually, in the 70s. But when you see discussions of discounted utilitarianism, this is seldom mentioned. And there are actually good reasons for that, as we'll discuss. So, as a simple model of pure intergenerational altruism, this has a couple of limitations, a couple of obvious limitations. Right, so first order intergenerational altruism preferences are limited because my altruism extends only to the succeeding generation. So in general, it could be that I have altruistic feelings towards all future generations, and perhaps there are some weights, Fs here, so that, and perhaps they're declining in the standard way, so perhaps I weight future generations' preferences lower and lower the further off they are. Or perhaps not. I need to make no assumptions about that. So in general, so you could get rid of this limitation by studying this kind of model where my preferences extend, my non-paternalistic preferences extend to all future generations, and this has been done extensively in the literature. So this is really the literature that I'm sort of tying into. There's a whole suite of models that do this and try to understand how these kinds of preferences relate to the properties of as-if paternalistic time preferences, which are just preferences of utility streams. But the second limitation is really not studied by any of these papers, and that's the assumption that intergenerational preferences are homogeneous, right? And so you can see immediately how that's working here, because I always use the same set of weights to evaluate the well-being of future generations in every succeeding period, right? And so that's a fine thing to do if, in fact, the future generations share my intergenerational preferences. But if they don't share them, then I'm being paternalistic, right? Then I'm evaluating their well-being according to my own concept of intergenerational altruism, not theirs. So can we write down a model that's non-paternalistic with respect to heterogeneous intergenerational altruism? So imagine that there are n types in the population, and each type is indexed by I, has some preference function vi tau. Okay? So this is the preference of type I in generation tau. And a given type is going to have a set of weights, FIS, on future generations, right? So we're not just, so these are weights on all future generations potentially, or only a finite number. But the important thing is that they're idiosyncratic to a particular set of types. And we're going to evaluate the welfare of a given generation by using a standard utilitarian welfare function. And so the welfare of that generation is just going to be the weighted sum of those, the welfare of the types within that generation, where these Pareto weights are some arbitrary Pareto weights. And what we're going to do is modify the standard homogeneous model so that my altruistic preferences apply to the social well-being of future generations rather than the well-being of my own type in future generations. Right? So this is a heterogeneous model because the well-being of future generations depends, of course, on the sum across all types in the population. Right? So what I'm saying is that my well-being today depends on the flow of utility plus the sum of the well-being of all future generations. And importantly, I'm evaluating the well-being of future types according to their own sovereign preferences, not according to my preferences. So this is a fully non-paternalistic representation of intergenerational altruism. Okay. So this looks like a bit of a complicated mess. It's a system of n times infinity equations, right? So n because there are n values of I, and infinity because tau takes all values from the current tau to the future, right? So all values from tau plus 1, tau plus 2. And it's n times infinity equations and n times infinity unknowns, right? So this looks like a complicated beast. But it turns out that this actually has a remarkable structure. So just to give you some intuition for the structure of this model, I'm going to look at the simplest case, that is heterogeneous, right? So again, I'm going to visit the first order model, so where my intergenerational preference only extends to the first generation. But in this case, that generation is going to consist of a heterogeneous set of types, right? So in this case, my evaluation of the welfare of the future generation doesn't depend on my own type, it depends on a sum across types who have different preferences. So now I only have no, I still have infinite equations. They're just much simpler, right? Okay, what I can do is multiply this system through by Wi, the Pareto weight, and sum across the Wi. And what I find is actually a very simple equation for the social welfare W tau, which is the weighted sum across all individuals in a given population. So that's just a simple one-dimensional recurrence relation. And I can solve it immediately, and what I find is that the social well-being is just exponential, right? And there's an exponential discount factor that is a weighted sum of the individual discount factors. This is quite intuitive. And I can substitute this result back into type I's preferences using this relationship here. And what I find is this expression, and I'm actually going to show you on the next slide something that's easier to interpret. So if I look at the discount factor sequences that come out of this model, right? So for an individual type I, in the homogeneous model, remember that in the first example I showed you, preferences are exponential for a given type I. But in the heterogeneous model, what I find is that in fact there are two discount factors that are relevant for type I. So one is idiosyncratic individual preference towards the next generation, beta I, right? But there's a second one which looks like a social discount factor. It looks like something that is a weighted sum of the individual discount factors. And this is a long-run discount factor that's common to all types, right? So this is actually a model in economics that's extremely well known. It's called the quasi-hyperbolic or quasi-exponential, depending on which terminology you happen to be using. The quasi-hyperbolic discounting model. It's the simplest possible model that you can find of present bias preferences. And so it's actually quite remarkable that in fact the generic case for first-order intergenerational altruism leads you to quasi-hyperbolic preferences for individuals. Now, and this, of course, has a long history. Wow, okay, 5 minutes left. We're going to go faster. So this has a long history in economics, going back to Philosophy Pollock. So another remarkable feature is that although every type in the population has quasi-hyperbolic preferences, social preferences are exponential. Now, if you're an economist, this should start ringing bells, because whenever we work with quasi-hyperbolic preferences, welfare analysis is very difficult because preferences are time inconsistent. But here you have a model that's generically giving rise to a population of present biased agents and simultaneously deriving from their preferences a time-consistent welfare criterion. So there's no paternalism in this welfare criterion at all. It's a completely time-consistent welfare criterion that has not been exogenously imposed. So a couple of observations. So heterogeneity causes discount factor sequences to revert to the mean, right? So if I were in a homogeneous model, these discount factors would just be exponential, but they get moderated in the heterogeneous model by the weighted sum, and that weighted sum pushes your discount factor sequence up if I'm less impatient than average, and down if I'm more impatient than average, right? And the second thing is that all types share the same long-run discount factor delta, which is this weighted sum of discount factors. So although the short-run preferences are idiosyncratic, the long-run preferences are common to all types. And that's true even though types' individual preferences are heterogeneous, right? So if we take these two observations to a general model, right, which is much more complex, we've got an infinite number of dependencies between different generations. So we're allowing intergenerational altruism to extend to all future generations. It turns out that both of these findings have exact analogs in the general case. So it's true that relative to a homogeneous model, heterogeneity causes all types of paternalistic preferences to revert to the mean. Otherwise, move up if they were less impatient, and move down if they were more impatient. And secondly, and this is really the main and strongest result in the paper, it causes all types, regardless of what their preferences are, to share a common utility discount rate asymptotically. So in the long run, regardless of what your preferences are, we all agree, if we're non-paternalistic, on how to discount future utilities. Right? So that's actually a really strong result. What it's saying is that all the idiosyncratic heterogeneity in types preferences washes out in the long run. And moreover, there's a kind of analog of some other results that you might know from other literature about the sort of the long-run discount rate being the lowest possible rate. So it turns out that there's a kind of analog of that in this paper, in the sense that when you solve for the social discount rate in this problem, what you find is a whole bunch of exponential components, but the long-run discount rate of all individuals in the population is the one that decays slowest. So it's the lowest discount rate that survives asymptotically. Okay, so nothing I've shown you so far has told you anything about the behavior of paternalistic preferences. So in particular, paternalistic time preferences could oscillate. They could be negative, which means that when I increase future generations' utility, when I decrease their utility, my well-being goes up. That's a pretty weird property, right? They could also be unbounded, right? So it could be that I have a whole bunch of bounded utility streams, but my well-being is unbounded. So in general, what we want to do is derive a bunch of conditions that ensure that all of these bad things don't happen. And there's a theorem in the paper that provides those conditions. And basically what you need is for individuals' intergenerational weights to decline roughly exponentially or faster, with some specific weight that depends on their the weight on the first succeeding generation. The final thing that I do is to apply this is going fast, so hopefully you'll discuss at the end. The final thing that I do is, so there's a very recent and actually lovely paper by Bruno Strudovici and Simone Galperti that axiomatizes a set of pure intergenerational preferences, pure intergenerational altruism preferences. And they basically adapt the Koopman's axioms. I don't know if you guys are familiar with that. These sort of original Koopman's axioms for discounted utilitarianism. They adapt it to a model of pure intergenerational altruism, and they actually find a representation that looks very similar but acts on non-paternalistic preferences rather than on utilities. And one of the things I do in this paper is use this model as an axiomatic justification for the focus on this beta-delta quasi-hyperbolic discounting model. Right? So it turns out that it comes out of their axioms that paternalistic as-if preferences from their axiomatic derivation of pure intergenerational preferences are as if we have these quasi-hyperbolic Phelps-Pollak preferences. And in fact, what delivers this is that exponential pure intergenerational preferences give you quasi-hyperbolic paternalistic time preferences. So this is what they show in this paper. Their model is, however, homogeneous, right? So again, it will be paternalistic if types preferences are heterogeneous. And so what you can do is give all types in a population, make sure that their intergenerational preferences satisfy the axioms of Galperti and Strudovici. So they all have preferences that are consistent with those axioms, but they act on social welfare, which reflects a distribution of heterogeneous preferences rather than on the same types of preferences. Okay? And what you can show is that there's actually no set of preferences in their axioms that delivers quasi-hyperbolic time preferences. So their finding is actually extremely weak. In the same way that we found with the original first-order homogeneous model delivering discounted utilitarianism, right? So we found that as soon as we introduce any heterogeneity, what you generically get is in fact quasi-hyperbolic preferences. And again, here what we find is that as soon as you introduce any heterogeneity, what you find is that you cannot replicate quasi-hyperbolic time preferences in the way that they suggest that you should. So here, excellent. Okay, I'm doing quite well. So here's just an example of how this plays out. So what I've done here is just pick 5 guys who have heterogeneous discount rates on future well-beings. And so the m's here are just the order of the model. So as m increases, I have altruistic feelings towards the first succeeding generation, the first 2 succeeding generations, the first 3 succeeding generations, etc. And each individual's preferences are going to be exponential with respect to well-being. So there'll be exponential discounted utilitarian preferences. So in the limit as m approaches infinity, what we actually get is the Strudovici and Galperti model, right? And you can see that, so in this case, individuals' paternalistic time preferences, this is what I'm plotting here as discount factors, okay? So what you would expect for beta-delta model is for these numbers to be whatever, some initial number, then to converge to a constant. And that's exactly what happens for first-order intergenerational altruism. Now their model corresponds to infinite-order intergenerational altruism. And you can see that as we make m larger, you get nothing that looks like this. In fact, the preference system is quite complex. But again, what you're seeing here is this convergence in equilibrium, and it takes longer the higher order the preferences are. This convergence in equilibrium to a unique discount factor that's shared by all agents. Okay, All right, so those are the conclusions. So existing models are all subject to a paternalistic critique if preferences are heterogeneous, and we think they are. And what we've done is introduce heterogeneity into a non-paternalistic model of pure intergenerational altruism. And we find that it causes preferences to mean revert. So homogeneous models are under or overestimating the weights on future utilities according to whether you are above or below the mean in impatience. And in the long run, this is really the strongest result in the paper, in the long run, everyone agrees on the appropriate utility discount rate if we're fully non-paternalistic. And existing derivations of exponential or quasi-hyperbolic time preferences, which economists know and love, are non-robust to the presence of heterogeneity. So, that's it.